All right, number 6. We have a review from 311 related rate. It says a 13-foot ladder is leaning against a vertical wall. We can see that in the figure. It says when Jack begins pulling the foot of the ladder away from the wall at a rate of 0.7 feet per second, how fast is the top of the ladder sliding down the wall when the foot of the ladder is 5 foot from the wall? Okay. So we're going to need to set up an image that looks like we have a right triangle. All right, so we have 13, and then it says how fast is it sliding down when the foot of the ladder is 5 foot from the wall. So we're going to say 5 foot from the wall. So we're going to solve for this unknown. So we're going to do Pythagorean theorem first to help us figure out when this is 5 foot away, how high is this? So we're going to get a squared plus b squared equals c squared. Plugging in 5 squared for a. B squared will still be b squared, and 13 for c. We get 25 plus b squared equals 169. We can subtract 25, and that will give us b squared equals 144. And if we take the square root of both sides, we will get that b equals 12. Okay, so we got to figure that out. Now, from the original problem, if I say a squared plus b squared, and we have the 13, this is a constant. We need to find the derivative to get the rate at which the ladder is sliding. So what I'll do is the derivative of this function, and this will give me 2a, and then the derivative of a with respect to time is going to be dA dt. And then derivative of b is going to be 2b, and then the derivative of b, thinking of chain rule, is going to be dB dt with respect to time. That's going to be equal to 0. Derivative of a constant, you're not going to multiply by 2, and then you just get 0. If you think about it as 169. Okay, this a is the base. They gave us the rate at which the base is sliding away from the wall. This is, I'm calling dA dt. That is the 0.7 feet per second. We also know that a is 5. So we get 2 times 5 times 0.7. All right, plus we have 2 times b. Now we did Pythagorean theorem, figured out that b was 12. So I have 2 times 12. And then we do not know dB dt. This is the rate at which the ladder is being pulled down. All right, so all we have to do is solve this for the one unknown. So this gives me 10 times 0.7. That will just give me 7 plus 24 dB dt equals 0. Subtract 7. And then divide by 24. So we get dB dt equals -7 divided by 24. And did they tell me what to round to? Round to 2 decimal places. Okay, so we're going to do 7 divided by 24. Now I know it should be negative, but I'll just let it give me the answer and enter my negative. So we get 0.29, and so we'll just leave that at about a -0.29, and it should be in feet per second. Negative 0.29 feet per second. Okay, so they say one or more is incorrect. It's only one part. 2, 5, 10. Let's just double check all the math just to make sure. 2, 5.7. Got too many. 2 times 5 times 0.7. We do in fact get 7. And then if we do a negative 7 divided by 24. We are getting negative 0.29 and it's 1/6. So negative 0.29 looks good. And we do believe that's in feet per second. When the ladder is 5 foot from the wall, top is sliding down at a rate of, maybe they don't want the negative because they already know it's coming down. So let me just get rid of the negative. Okay, so since they know it's coming down, it should be negative, but since they know it's being pulled down, I guess you don't need to put the negative there.